Hello students, let me introduce you to the chapter Statistics. In this chapter, we shall look into the introduction, measures of dispersion, range, mean deviation, variance and standard deviation, analysis of frequency distribution. Now in introduction, we know that statistics deals with data collected for specific purposes. We can make decisions about the data by analyzing and interpreting it. In earlier classes, we have studied methods of representing data graphically and in tabular form. This representation reveals certain salient features or characteristics of the data. We have also studied the methods of finding a representative value for the given data. This value is called the measure of central tendency. Recall mean, that is arithmetic mean, median and mode are three measures of central tendency. Also recall that we calculate the mean of a data denoted by x bar by dividing the sum of the observations by the number of observations, that is x bar is equal to 1 upon n summation I ranging from 1 to n x I. Also, the median is obtained by first arranging the data in ascending or descending order and applying the following rule. If the number of observations is odd, then the median is n plus 1 upon 2th observation. If the number of observations is even, then median is the mean of n by 2th and n by 2 plus 1th observation. A measure of central tendency gives us a rough idea where data points are centered, but in order to make better interpretation from the data, we should also have an idea how the data are scattered or how much they are bunched around a measure of central tendency. Consider an example of cricket team and its batting performance in last 9-day matches. Let us assume that batsman A scored 60, 55, 50, 50, 40, 45, 55, 45 and 50 runs. Batsman B scored 70, 30, 60, 20, 50, 90, 40, 80 and 10 runs. Batsman C scored 20, 25, 15, 20, 20 in 7 innings and did not get to bat in 2 innings. The mean and median for this data are: for A, B and C, the mean and median are as follows: 50, 50, 20 and 50, 50, 20. This tells us that average performance of batsman A and B is the same and much better than that of C, but this is only part of the story. Now, let us plot the scores as dots on a number line. For batsman A, you can see the scores are ranging between 40 to 60 and they are clustered here. For batsman B, they are scattered from 10 to 90, and for batsman C, you can find they are all lying between 10 and 30. These diagrams show that average score of A and B is the same. The score distribution of batsman A is more compact than that of B, whose score distribution is comparatively dispersed, that is scattered widely. When A goes out to bat, you are quite sure that he will score around a half century. But when batsman B goes out to bat, you keep your fingers crossed. you don't know whether he will be out for a duck or whether he will hit a century, though his average is also half a century. As far as batsman C is concerned, though his score is low, he is quite reliable. When he goes out to bat, you are pretty certain that he will score around 20 runs. We can see that the dots corresponding to batsmen A and C are close to each other and are clustering around the measure of central tendency, that is mean and median, while those corresponding to batsman B are scattered or more spread out. Thus, the measures of central tendency are not sufficient to give complete information about a given data. Variability is another factor which is required to be studied under statistics. Like measures of central tendency, we want to have a single number to describe variability. This single number is called a measure of dispersion. In this chapter, we shall learn some of the important measures of dispersion and their methods of calculation for ungrouped and grouped data. Now, let us discuss about the measures of dispersion. The dispersion or scatter in a data is measured on the basis of the observation and the types of the measures of central tendency used there. There are following measures of dispersion. First, range. Second, quartile deviation. Third, mean deviation. Fourth, standard deviation. In this episode, we shall study all of these measures of dispersion except the quartile deviation. Now, let us first discuss about range. The difference between the maximum and the minimum value of a data series is called its range. The range indicates the total spread of the data, that is 100% values lie within the range. In the example given earlier, for batsman A, range is equal to 60 minus 40, that is equal to 20. For batsman B, range is equal to 90 minus 10, that is equal to 80. Thus, range of a series is equal to maximum value minus minimum value. The range of the data gives us a rough idea of variability or scatter, but does not tell about the dispersion of the data from a measure of central tendency. For this purpose, we need some other measure of variability. Clearly, such measure must depend upon the difference, that is deviation of the values from the central tendency. The important measures of dispersion which depend upon the deviation of the observations from a central tendency are mean deviation and standard deviation. Let us discuss them in detail. What do you mean by mean deviation? Recall that the deviation of an observation x from a fixed value a is the difference x minus a. In order to find the dispersion of values of x from a central value a, we find the deviations about a. An absolute measure of dispersion is the mean of these deviations. To find the mean, we must obtain the sum of observations, but we know that a measure of central tendency lies between the maximum and the minimum values of the set of observations. Therefore, some of the deviations will be negative and some positive. Thus, the sum of deviations may vanish. Moreover, the sum of the deviations from mean x bar is 0. That is, mean of deviations is equal to sum of deviations upon number of deviations, that is equal to 0 upon n is equal to 0. Thus, finding the mean of deviations about mean is not of any use for us as far as the measure of dispersion is concerned. Remember that in finding a suitable measure of dispersion, we require the distance of each value from A, central tendency, or a fixed number A. Recall that the absolute value of the difference of the number gives the distance between the numbers when represented on a number line. Thus, to find the measure of dispersion from a fixed number A, we must take the mean of the absolute values of the deviations from the central value. This mean is called the mean deviation. Thus, mean deviation about a central value A is the mean of the absolute values of the deviations of the observations from A. The mean deviation from A is denoted by MD, that is A. Therefore, MD, that is A, is equal to sum of absolute values of deviations from A upon number of observations. An important remark here: mean deviation may be obtained from any measure of central tendency. However, MD, that is mean deviation from mean, and median are commonly used in statistical studies. Let us now learn how to calculate mean deviation about mean and mean deviation about median for various types of data. Mean deviation for ungrouped data. Let n observations be x1, x2, x3, so on xn. The following steps are involved in the calculation of mean deviation about mean or median. In step 1, we calculate the measure of central tendency about which we are to find the mean deviation. Let it be A. In step 2, find the deviation of each xi from A, that is x1 minus A, x2 minus A, x3 minus A, and so on till xn minus A. In step 3, find the absolute values of the deviations, that is drop the minus sign if it is there, that is absolute value of x1 minus A, comma x2 minus A absolute value, and absolute value of x3 minus A, and so on absolute value of xn minus A. In step 4, find the mean of the absolute values of the deviations. This mean is the mean deviation about A, that is mean deviation A is equal to summation I ranging from 1 to n absolute value of xi minus A upon n. Thus, mean deviation x bar is equal to 1 upon n summation I varying from 1 to n absolute value of xi minus x bar, where x bar is equal to mean, and mean deviation m, that is equal to 1 upon n summation I ranging from 1 to n xi minus m, where m is the median. In this episode, we shall use the symbol m to denote median. Let us now illustrate the steps of the method in the following example. So, students, today we learnt about different measures of central tendency. In the next session, we shall continue by calculating the mean deviations using mean and median. Thank you.